Good morning, good afternoon, good evening. Welcome to the AI 2030 show. My name is Xiaochen Zhang, and the CEO of FinTech for Good, and also the Executive Director of AI 2030. And today I have a very exciting guest, and Anit. And maybe that's before we start dive deep into our conversation. And can you introduce yourself?
Sure, thanks, Yashan. Hi, everyone. I'm Ankit Virmani. I am a senior cloud data architect at Google, and I work with customers on helping them build their data analytics and machine learning platforms in an ethical and a responsible manner. Very, very excited to be on this show.
Awesome. That's yeah. So in your job, probably that's you have helped many customers to build, and we all know that within the responsible AI, that's um, there are many things that need to be done correctly. So then the final result can really be beneficial to the humanity and to the customers and one particular, aspect which is very challenging, and that is around the bias. And we have already seen many news on the news where that's bias, AI related bias creates negative results.
Yeah.
No matter is bias against a certain race or certain gender or and where that result can be detrimental. And my question, the first question to you is, how does bias can manifest in machine learning?
Yeah, that's a great question. So, from my perspective, I view machine learning as two parts. One is the data that goes into the machine learning models, and then the second one is the actual machine learning that is done on the data. So the bias can prevail in either of those stages or both of them. So, like when we talk about data, there could be inherent bias in the data itself, the data that we are gathering from 1940s, 50s, 60s, 70s. Because of the societal prejudices and any other factors, the data can be inherently biased. There could be a misalignment between the features that we are looking for and the business requirements that could create bias. There could be missing data for certain segments, and there could be a lot of data for certain other segments when it comes to demographical segments or other segments. That could be another kind of bias. Or there could be a non-random split between training and test data that we are taking for the models that could cause bias. Now that's the data part or the data engineering part. In the ML part, even if there is bias or no bias in the data part, there could be some practices that can augment or enhance that bias in the machine learning engineering part. One could be the features itself producing biased models. The other one that's very interesting is some data scientists that we work with or I've worked with in my career, they have an emotional attachment towards certain machine learning models. They would want to use certain models over the other because maybe their research wasn't that, or they have academically been inclined. Some models can actually inherently be biased by the way they train, by the way they do repetitions or distribute data while training, etc. Or there could also be biased when you're annotating supervised models, because if there is a human that's involved in annotating a model, they might have a bias in their mind while they're annotating an image or annotating anything else. So those are some ways, or those are some sources that can introduce bias, which can percolate itself throughout the machine learning operations cycle. And then it becomes difficult to sort of remove it. But if you know the sources where it's coming from, then you can target that exact source and start addressing it. But these are some of the sources where the bias can creep in very, very quickly.
Yeah, and as what you can, as what you explained, that bias can come to a machine learning model at its life cycle, right?
Yeah.
And are there any way to detect those bias easily, and especially for those at the business level, and of course that's especially from the user side or from the business decision maker side, they are not model builder, and then they are not technical,
Yeah.
and but they are potentially also a decision maker as when they interact with the customer, when they see the final result, and then when they just go back to the model, the team who built model, and how can the model builders help them to just easily navigate, or how can they, or what skill set they need to just acquire to make sure that they have the ability to identify where are the source of bias.
Yeah, that's a great question. So, from a business perspective, there is a lot of value in the business folks knowing the functional aspects of the data that they're looking at, right? Like for example, if we talk about any bank in Europe or uh, North America or Asia, and we are talking to a business analyst or a chief fraud detection officer or anyone who's on the business side, they knowing the data patterns that they have been seeing and the fraud detection patterns that they have been seeing at a functional level can really help. Like, for example, someone who's on the business side knowing that, oh, we have been flagging more people of color for fraud than other races, and we still don't know the reason behind that. Even having that kind of an insight of what the data is doing to the business decisions can now trigger a conversation between that business person and the AI team. And then the AI team or the data team can go ahead and profile the data to figure out whether certain population sets are represented more or less in the data itself, and then divide the data between population groups. So, in my example, when I was talking about the fraud, uh, there's a very classic example where in Chicago there is North Chicago and South Chicago. There are certain communities there which have biased data models in the financial industry. So the business user knowing that North Chicago certain segments are considered more fraudulent than the other ones, and that triggering a conversation to the actual data scientists who can now profile the data and see like, oh, okay, so there are certain demographic segments in this zip code that are not represented well in our training data set, and that's why they're always being considered for fraud or non-fraud. So that's how this conversation trickles down, and again it boils down to like it coming from the business or it being detected from the data team, and then they doing the data profiling, because the first step has to be profiling the data. Once you profile the data, then you start identifying the gaps at, oh, this is not a gap in data. This could be a gap in training or testing split. We might be splitting the data incorrectly. Now, if they like see that, okay, that is also random, then they can come to the third part saying, oh, maybe my model is inherently producing biased results because my training testing is perfectly random. My data is not that biased. So it's like a very stepped approach. It can come from the business, then it can go to the data science or engineering team, and then they can take these steps to identify where that bias is happening through these technical techniques.
Thank you. Yeah, this is very helpful, and in general, in the AI era, and a lot of time that there is self doubt from the non-technical folks. Can I survive in the AI era? And does my expertise still valid? And where that I can contribute? And I think from your answer, it's very clear that's part of the human machine collaborative intelligence, where that's you if you are technical, that you can just directly interact with the machine that
Yeah,
way. But if you are not technical, and from your common sense, from your industry specific knowledge, and you understand the pattern, you surface the problem, and then
yeah,
those actually just inspire a lot more deeper dive, and improve the quality of AI and all that. So that is
totally.
definitely very helpful. And you talk about the source of bias, and can you give us some real life examples, and where bias has affected the society, company, or individuals?
Yeah, so many. There was one very interesting example of Dutch child scare scam where there were some families that were incorrectly tagged as fraudulent families while they were asking for childcare support, and those families were asked to give back the childcare support money that they took from the government. And this came to light, I think, in 2017 or 18. I don't exactly remember the date, when a third party independent agency audited all this. And they found out that there were a lot of families who were asked to repay the government the childcare payments that those families were taking, and they were tagged incorrectly. They were actually authentic, right families who needed care or who needed childcare payments. And going one step further, there were a lot of divorces because of this. There were families that got broken. There were people who got so poor that they did not have food to eat because they had to repay the government all the money that the government had sent them for support. People could not go to, children could not go to study, etc. So this was one classic example where the AI models that were predicting whether a family is a fraudulent family or not were biased. And the interesting part is they were biased towards families that had twin kids. So that's one example where bias impacted the social fabric so much that it led to families' destruction, right? The other example was a classic
Can you
Chicago
give a little
example.
bit more details about this? And then, so the bias against the twin, basically, because of the data of the twin are very
Yeah,
similar. They said, you are talking about not two people, but then maybe one person, and then you create two people, and then that's how
yeah,
it just predict that this is more fraudulent. And what's the story behind that?
yeah. So yeah, I mean, I don't know the atomic details, but what I read was that the families that had twin kids, basically, like the uh, a, a family that had like either fraternal twins or whatever the twins are, they tended to be more fraudulent than the families that had single children or non-twin kids, basically. And that was because of some bias that the data had from early on. There might have been some families that would have actually been uh, fraudulently asking for childcare payments, and coincidentally those families had twin children, like two boys, two girls, a girl and a boy, or something like that. So since the model always thought that, oh, this family has twin children, this will always be a fraudulent family, because of the bias that the model had, it would always tag every family that had twins to be a fraudulent family. So there was a prejudice that the model was trained on,
Mhm.
and that's the prejudice that the model took with it to sort of predict that every family that had twin children would ask the government for money that it should not be asking for, and that's why it asked them to repay the
Got
money.
it. Yeah, and now you have one example about if you have twins and you need to worry about AI, and what other examples you may have?
Yeah. The other one was very, very popular. I think it was in United States, where uh, people of color were always thought to be healthier than white people, basically. And that was because the models were trained on a parameter which was indicative of the healthcare costs spent on the certain demographic, and the healthcare cost that was spent on white people was always more than that of people of color. And that made the model think that, oh, since I'm spending less money on people of color, they are always healthy. But that was not the case. That was actually the opposite. The people of color were getting less care in the hospitals, and that's why the spending was less, which was leading to the people of color being more unhealthy because they were not getting timely care. So that healthcare cost was getting reduced because they were not getting timely care, and those people of color were getting more unhealthy because of that. But the model was thinking that they were healthy, that's why they were not spending enough money in the hospitals. When there was another third party that brought it up to the healthcare government agencies and stuff, and with a lot of effort they removed that parameter from the model training, the healthcare costs. And then the model started producing much more accurate results. Then the model would produce proper results where it could identify who needed the most care, regardless of the color and the race. This was another example where I don't even know how many people would have been at a loss of their health just because of the fact that they were not spending enough money in the hospitals. So the healthcare financial systems were biased here, right? That led to the quality of healthcare being impacted. But the good part, or the silver lighting in this case, was that those models removed that column that was, or the field that was leading to the bias, which was the healthcare costs, and they started producing better results. So this was another major example where bias impacted the society with respect to the healthcare quality.
Awesome. Yeah. So as again, those examples show that bias can come into a model really at any stage. And, the last example is, particularly interesting here that, just you define variables there, and then whether they have cultural relationship, or how do you define that cultural relationship itself, or just adding more parameter. A lot of time that's some of the models claim that because we have more variables that make us have better way to
Yeah,
predict and with better result, but not necessarily, right? And then you have a variable which is so disruptive, and then that actually just really create a result which may just impact the society very negatively, and which also against the real purpose of that
that,
prediction.
yeah.
And a follow-up question on that is, since bias can enter into a model, at any stage, and then the result can be, detrimental. And what are some of the, mechanisms, or ways to really mitigate the bias, and especially in the financial service industry?
Hmm. Yeah, that's a good question, and it's not a simple one, to be honest. But let's try, right? So, uh, the first part of this segment that we were talking about was the sources where the bias can manifest, right? I think that question in itself has some of the answers hidden in it. Like, and you also made a very good point on how a non-technical user can contribute to ethical AI. So let me start there, right? Like, knowing the data functionally is absolutely and very, very important to know where the sources of bias could lie. Having a functional knowledge of data is far more important than having technical knowledge of that data with respect to how that data could be consumed, how that data could be used or misused, or how that data could have inherent bias that could be coming from years and years of that data lying there with no one looking at it. So, in fintech as well, in financial services as well, having appropriate knowledge about regulations, about fraud, about whatever the use case is, and knowing what kind of data today exists. And it's not hard to keep abreast of that. There are a lot of journals that business users can read, or anything. So knowing the data is the key, the first thing to even start thinking about mitigating the bias, right? Once that is known, then there could be close collaboration between the business and the technical people, and they can start working on removing sensitive groups from the data, right? They know that, okay, this particular part of the data can actually lead to a lot of bias in the models. This is the demographic segment. Or for example, we don't need a zip code to train a model to give credit scores to anyone. Zip code, a poor person can live in a zip code where there could be rich people too, right? So like, trying to remove those sensitive groups of data. And the second example that I was giving was the healthcare cost, right? So trying to identify those groups and removing them can help training the models. And before, like, when you remove the bias, and training the models regularly even after that, that helps, because that gives the data science teams the ability to monitor whether the models are becoming inherently or increasingly biased as new and new data is coming. So training those models regularly and having a close eye or monitoring those models can really help. And then not being emotionally attached to a single model just because someone did a PhD in that model or studied that model for the whole life. Having an open mindset to try out different models and identifying which one gives you the best result can help. Because as I was talking about it before, some models can produce inherent bias than the other ones based on how many folds they have and whatever the technicality is. Uh, and the last part is once you have identified the bias, just the identification is not enough. Putting a feedback loop to start reducing that bias in your production or whatever the environments is by connecting the bias detection piece of your project to the actual data collection piece, that also helps, like having appropriate feedback loops. So I know this is not an easy answer and it depends on where the bias is, but these are the methods where or using which you can try to mitigate it. Another very popular one is having a combination of real data and synthetic data also helps in case your real data is really biased. There are a lot of libraries and techniques now that can help create synthetic data so that the data starts looking equitably distributed across segments. So that's also another potent way to start thinking about mitigating bias.
That those are very helpful. And a follow-up question on that is, I heard a lot of claim that from the technical folks and also business folks, like models inherently have bias, and where that's it's really just you make a intend to inform the choice, where that's which model have less bias, and then the ones which you're using, and then naturally there will still be bias. And then have you, or are you aware of any practice that's, if because it's informed decision where that you chose certain model, you already know, what the bias are, but you really cannot take them, remove them 100%. And how those people who are, being targeted within a model or being impacted by the model, and are there any, way to still, address their problem and address, the fact that, then the model are biased toward them, or then they are impacted without changing the model itself?
Yeah, that's a great question. So if for some reason we can't remove or reduce the bias, there could be multiple reasons to your question. I think it's extremely responsible to at least tell the end users that are being impacted that please note that our model might produce biased results. This is not the final result. And then there could be a human in the loop thing there. That if the model is producing biased results and we consciously know that, there could be a human in the loop team that could be sitting and that could educate the end users, or that could sort of override the decisions that the model is making and try to think what decision should be the right one. So there are multiple ways, like we should introduce explainability in the models, which explicitly tells that particularly targeted group, unfortunately, that they were in the minorities or they were part of the biased group. And then the second, that's the informed part. And then the second one is taking an action. We can have a human committee, and I think we should anyway have a human committee as part of the new AI rules that have been passed in Europe. They talk about fairness in AI, and one of the parts there is human agency and oversight. So, if we know that the model is biased, then the human agency and oversight to those models should be even more, because we know consciously that they're biased. So, there could be some human intervention there that can override the decisions of models and then maybe make some fair decisions. So, that's the operate or the act part. So there's an inform part and then there's the act part in case you can't do anything with the model.
Awesome. Yeah, I think those are very helpful and also implementable, right? And then if any organization are building AI now, and then also understand there are unintentional consequence, but
Yeah.
that as part of mitigation to come up with a plan, and then including the communication piece, including the decision making mechanism, and then bring additional process into that. I think that itself is tremendously helpful. And this has been very insightful, and thank you very much for your time. And I hope that our audience have learned as much as I did. And again, thank you very much. Really appreciate your insights.
Thank you so much for having me, and hope you have a good day. Thank you.
Thank you.